Hi, sixth graders. Today, this is Mrs. Gall, by the way. Today we're going to talk through some special solutions when it comes to equations. So go ahead, open up to a fresh page and put special solutions at the top of your page. We're going to start by solving using some of the strategies that we've learned about in previous videos, specifically our multi-step equations. So we're just going to solve like normal, and towards the end you're going to see why this one has something special about it. So let's start solving by getting rid of our parentheses first. I see parentheses on this left-hand side. If you need more time to write this down, pause now. All right, you guys, so we're going to start solving by distributing our -2 that's here on the outside of the parentheses. Remember, when you're distributing a negative, that's going to change all of the signs that are inside of our parentheses. So a -2 times a positive 3r is going to give us a -6r. And a -2 times a positive 4 is going to give us a -8. We're going to set that equal to our pieces that were on the other side, -6r minus 8. Now, if I keep solving, you might notice something already. You might notice that our sides are looking very similar at this point, but let's keep solving and see what happens when I go to try to solve for r. So I want to start by moving. I like to put my variables on the same side first, and I usually start with my smallest variable, but when I'm looking at my variables, I actually notice they're the same thing, -6r. So I guess I'll just move this one over to the other side. Since it's a -6r, I'm doing the opposite of subtracting, which is adding 6r. But you may notice my 6r's cancel out on the left. I'm left with -8. But then -6r plus 6r, they're actually going to cancel out on the right as well. So all we're left with on the right is -8. We have no r's left in our problem. We ended up with -8 equals -8. In a situation like this, where our variable ends up canceling itself out, and we are left with sides that are in fact equal to each other, -8 is equal to -8, we call this an all solutions problem. What that means is any possible number that you plug in for r will work. If you plug in a 1, it will work. If you plug in a -8, it will work. If you plug in 100, it will work. This is a special type of equation. We know it's an all solution because the variable disappeared, it canceled itself out, and our two numbers that were left were equal to one another. Let's test it out. Let's do, I don't know, what number should we do? 5? I don't know how well this will work out for us, but we'll try it. So in place of r, I'm going to place a 5. Just going to rewrite out my equation first before I start doing any solving. And make sure on the other side I plug in a 5 as well. Okay, we can start with our parentheses. 3 times 5 is 15. 15 plus 4, I can either add first or I can do distributive property first. I'll just add first to get 19. And then outside of the parentheses was a -2. So 19 times -2 is -38. Let's see if we get that on the other side. -6 times +5 is -30. -30 minus 8, add the opposite. -30 plus -8, also -38. So you guys, no matter what number you were to plug in there for r, it would work. This type of equation is a special solution. All solutions would work. So this is what I'm looking for with your answer, all solutions. Let's try another one. 3 times the quantity of y minus 5 plus 25 equals 3y plus 10. Let's start by using distributive property and solving like we would a typical multi-step equation. 3 times y is 3y. 3 times -5 is -15. I still have a plus 25 that was outside of the parentheses, so I bring that down. And I set it equal to all that was left on the right, 3y plus 10. I actually have some like terms on the left, so I'm just going to combine those together before I go any further with moving things side to side. If I have like terms on one side of my expression, I don't have to use um, inverse operations to combine them. I just add them together like I would in an expression. So negative 15 plus 25, that would give us a positive 10. And then I still have 3y on this side, and the other side still has 3y plus 10. At this point, maybe you're noticing that both sides have the same exact expression on them. So at this point, my little alarm is going off that this is likely a special solutions problem since the sides are identical, but we can continue moving just to see what happens. So I notice my 3y is my smallest variable, but it's actually the same variable on both sides. So when I go to subtract 3y from both sides, my y's end up canceling out everywhere, and I'm left with 10 equals 10. When your y's disappear and all you're left with is the number 10 equal to 10, and that is true, 10 is equal to 10, we would say all solutions work for this problem. Any number that you plugged in there, you could try it if you wanted to, would work as an answer. All right, you guys, you try this last one on your own. Go ahead and pause the video, and when you're ready to see me work through the answer, press play. Hopefully you distributed your 3 to begin with. 3 times 4h is 12h, and 3 times negative 2 is negative 6, and then I had plus 15 outside the parentheses, equals 12h plus 9. From there, you have some like terms on one side of your equal sign, so you're just going to add those together before you go any further. So negative 6 plus 15 gives us positive 9. And you still have that 12h at the start of that equation. And you set that equal to what was on the other side, 12h plus 9. At this point, you're noticing that your sides are looking identical. That's a signal to you that you have a special solution problem that's going to end with all solutions as your answer, but you can keep working to get to the point to make sure that you don't have h equal to anything. So when I move my h's, I'm taking the inverse of a positive h, which is a negative h, and that ends up canceling out all of my h's on both sides. So I have no h's left, and I have 9 is equal to 9. That is true, 9 does equal 9, so I would say that all solutions work for this equation. Yes, we will count it wrong if you don't identify that it's an all solution problem, so please make sure you're identifying that all solutions would work because 9 does equal 9. Okay, let's move on to a new type of problem. 14 plus 8w equals 4 times the quantity of 8 plus 2w. Write that down now. Start like you would with any other equation by using distributive property. I'm going to take my 4 and multiply it by both of the pieces inside the parentheses. 4 times 8 gives us 32. 4 times 2w gives us 8w. On my left, I still had 14 plus 8w. From here, I'm going to go ahead and combine or move my variables from side to side. I have no like terms on the same sides that need to be combined, so that's when I start to move my pieces to get like terms together. So I'm going to move my 8w. It's my smallest variable, but it's actually the same thing on both sides. So when I go to subtract my 8w from both sides, it ends up canceling out all of the w's. And I'm left with 14 equals 32. Is that true? Does 14 actually equal 42? No. This is what we call a no solutions problem. When your variables cancel each other out, so you have no variable left, and your constants that are left do not actually equal each other. This means that there's absolutely no solution that can be plugged into that equation to keep it true. So this is what we call a no solution. I'm looking for if you can identify a no solution versus an all solution problem. So we do need you to state that this is a no solution problem. Let's move on and try another one. Negative 5x minus 14 equals 2 times the quantity of 2x plus 3 minus 9x. Let's start by getting rid of our parentheses first and then combining like terms. On the outside of my parentheses, I see a 2 that needs to be distributed. Reminder, it only gets distributed to the pieces inside the parentheses. 2 times 2x is 4x, and 2 times 3 is 6. Outside of the parentheses, I had a minus 9x. That was equal to, on the left-hand side, negative 5x minus 14. On the left-hand side, I have a few terms. I have some that can be combined. So I notice I have a 4x and a negative 9x. Those are like terms, and they're on the same side of the equal sign, so we can just combine them together without having to use inverse operations. 4x plus a negative 9x would give me a negative 5x on this side. The positive 6 constant just gets left alone. And then my left-hand side stayed the same at negative 5x minus 14. Notice at this point, we're going to start combining like terms from side to side, so we're going to use those inverse operations. And if I go to move my variables first, and I always like to look for the smallest variable to move first, I'm noticing they're the same. So I guess I'll just move this one first by adding 5x. But when I add 5x to both sides, my x's end up canceling each other out because I have a pair of opposites, negative 5 and positive 5. What's left on the left-hand side is negative 14. What's left on the right-hand side is positive 6. Does negative 14 actually equal 6? No, and my variable disappeared. That's a signal to me when my variable has disappeared and canceled itself out. That's a signal this is a special solutions problem, either an all solutions or a no solutions. How do I figure out which one? Well, I ask myself if the ending piece is true. If this does not equal this, that is not true. That means this is a no solution. If it did equal that, that's when I know it's an all solution. So that means this equation does not have any solution that will work in place of x. No solution. That's what we're looking for if you can identify that. Try this last one on your own. Press pause and press play when you're ready to hear me walk through the answer. Hopefully you started by using distributive property with your 3 that was on the outside of the parentheses. 3 times 2y is 6y, and 3 times 4 is 12. Then you had a positive y on the outside of the parentheses. Oops, that's kind of lagging there, sorry. There we go. Set equal to 7y minus 8. On the right-hand side, I have a couple of terms that can be combined. My 6y and my y. I can add those together to get 7y. I don't have to use inverse operations because they're on the same side of the equal sign. From here, now I'm going to start moving terms from side to side, so this is where my inverse operations come into play. I'm going to start by moving my y's. 7y, opposite of positive, would be negative. But when I do minus 7y, I end up canceling out all of my y's. That means I'm left with negative 8 on the left equal to positive 12 on the right. Is that true? Does negative 8 equal 12? No. And since my variable has disappeared, that's a signal to me this is a special solution, and since the sides are not equal to each other, it's a no solution problem. Sometimes we'll abbreviate SOL with a period. All right, you guys, those are our special solutions, all solution and no solution. Check in with your teacher if you have any additional questions.